Good afternoon, guys. Now we have a series of Parse talks that will run through the end of the afternoon. This first one is called Getting Started with Parse. Enjoy.
Hi, everyone. I'm Christine. This is Fosco. Welcome to Getting Started with Parse. Today, we'll talk a little bit about what we do, why it matters, and then we'll walk through a sample app showcasing the different ways that you can use Parse and our functionality. Apps today can't exist in isolation. It's not enough for your app to be kind of cool on just your phone. There's got to be a way for one device to affect what another device sees. And for that to happen, there's got to be something in the middle, something receiving requests, sending data back and forth. That's a backend. The problem is, when you're focusing on what your users want, what will get traction, what people are interested in, having to worry about the glue in the middle, having to worry about this stuff that the users don't even see, it's hard. Let's take a look at all the different parts that go into this glue in the middle, this boilerplate. First, you need a server. You need some machine out there somewhere listening for your requests. Then you probably need a database, some central store if you're going to be storing or retrieving data between your devices. Then, an authentication layer, another implementation of a login sign-up flow, something that you do for all of these different apps just so you know which users are making requests and to make sure that those users are only accessing the data that they're supposed to. Then you have this layer between the client and the server. You have to, this might be as simple as just keeping a map of URLs and working with JSON, but that's only if your platform supports JSON natively. You might have to end up pulling in a bunch of other libraries to handle manually serializing your request, deserializing your response, and then spending 20 lines plucking attributes off one and putting them on your native objects. Don't get me started on writing another caching layer either. And then, if your app goes viral, that's great. Tons of new users, lots of new interest, except for that week that you lose making sure your servers stay up and working with your database indices and trying to keep things trying to make sure things aren't too slow. That's a week that you spent preventing a negative experience, rather than making sure your users are having positive ones, rather than making sure you're building things that will attract your users and keep them there using your app. Only after that, only after all of that, all of which is basically boilerplate at this point, only then do you get to focus on what makes your app special, what makes your users excited to be using your product. You build games, or social networks, or apps that doctors use, or apps that families use. That's what makes your app special, not how well you implemented your caching layer, or authentication flow, or your database indices. Focus on what your users are touching, feeling, playing with, not the rest of the stuff. Hopefully by now, all of you have been using the F8 apps, or have at least taken a look at the F8 website. This is something that we decided to build in-house, but needed to be built quickly and needed to be easy for any member of the staff to update. All three of them, iOS, Android, web, all point at the same Parse app. And that means that any of the member of the staff can come in, update titles, send push notifications, and make sure that the F8 experience is consistent. This also allowed the one iOS person working on the app to focus on making the animation smooth, making it feel very iOS-y. And the Android person could focus just on the parts that made the Android app feel snappy. They didn't have to worry about what the data model was, how to keep it consistent, any of that. We took care of that. We know you don't want to reinvent the wheel, so use ours. Our clean APIs and modern SDKs make it simple to build whatever functionality you want on whatever platform you want. anything we can't abstract away, we make dead simple so you can get started on what matters.
Parse is the platform of choice for more than 500,000 apps, so we know how to manage a backend. You could save a lot of time and money letting us handle operations for you, and you get a fast and reliable collection of services. Starting with Parse Core, you get a fast and powerful database that's a joy to work with. It's so easy to get started. Just create some Parse objects, set whatever keys you like, and save it. You don't have to worry about setting up, predefining all of the columns and keys and what data types you'll be storing. We can take care of that for you. You also won't have to worry about more advanced things like database indices, as we at Parse will monitor your actual usage and create whatever indices are appropriate. You'll have full access to your data via the parse.com data browser. From there, you can manage all of your collections and schemas, create and update objects, and you can even import and export data to and from your app. Push notifications are great. They're a direct channel to all the people using your app. You could use them to alert them about new activity in your app. Maybe someone liked a comment or posted a new photo. Or maybe you haven't seen them in a while and you want to re-engage them and bring them back. With Parse Push, you can broadcast to your entire audience or write a very targeted query and send things to only a select group. We eliminate the complexity of building all these different interfaces to Apple and Google and Microsoft. I've done it in the Apple and Google case, and it's non-trivial to get all that working, and I didn't even have to worry about scaling it. You can even run A and B testing experiments on Parse and find out which messages perform better with your specific audience. Parse takes it even a step further by supporting additional devices like the Kindle and the Nook, and as announced yesterday, pretty much any hardware device as part of the Internet of Things. We think it's the easiest and best push platform around, and I think you'll agree. Another benefit of using Parse is security. Since we joined the Facebook family about 2 years ago, we've been battle tested and code audited, and we're confident that we're providing an easy-to-understand security story for our developers. We manage, for your data, we offer a comprehensive set of class-level and object-level permissions that gives you fine-grained control over who can do any of the different things in your app. And for your users, we take care of all the complexity around passwords, forgotten passwords, email confirmations, so you don't have to. We also support social login with Facebook and Twitter and handle creating or linking a Parse user for them. Parse has built out even more backend functionality for you. With Cloud Code, you can write a cloud function, deploy it to Parse once, and access it from all the different platforms. Run some code anytime an object is saved or deleted in your app, where you can do some validation, maybe change the operation that's happening, or just reject it entirely. You can also communicate with external services directly from Cloud Code. With background jobs, you can run more complex logic, ad hoc, or set it up to run on a schedule. With Parse hosting, you can host a static website or build a fully dynamic application using something like the Express framework. All across Facebook, we use Parse to build out new apps. If you visited the Oculus booth and signed up for a demo, I think all the slots are full now, you'll be using a Parse React web app hosted on Parse, which uses Parse Core and Cloud Code and background jobs. Reserving a demo slot is done with a cloud function. It checks to make sure that the slot isn't overbooked and saves the reservation. And then 15 minutes before your demo, you'll get a text message reminding you that's done with a background job that's running every couple of minutes to find the next slot and go ahead and use Twilio to send all the messages. With all of this and everything else that Parse offers you, we think you'll agree. Parse is your team.
We try to make Parse be wherever your users are. On mobile, this means we have SDKs for Android, Windows Phone, and iOS. On desktop, OS 10 and Windows 8. On the web, We have a JavaScript SDK and the brand new Parse React integration we announced yesterday. For server-side apps, we have an official PHP SDK, and our JavaScript SDK works just as well in Node.js. There are also a number of third-party integrations for your favorite server-side language that wrap Parse. For those who like to blur the lines between platforms, we have a Xamarin SDK that lets you build out to iOS and Android. And for the gamers and VR fiends out there, our Unity SDK's got your back. For everything else, whether you're a smart refrigerator or a shell script, we've got our embedded SDK announced yesterday as part of Parse's Internet of Things launch, and a plain old REST API. Today, we'll walk through building AnyJoke, our collaborative humor site. It's a Parse React app, so it'll be JavaScript samples you'll be seeing on the screen. But we'll show the equivalent samples in iOS and Android as well. After the talk, we'll have links to the GitHub repository, where we have a full Parse React app you can play around with, and a link to the demo site, so you can play around with it in person and kind of see how it feels. This is how the site will work. Someone comes in and proposes a setup, the beginning of a joke.
What's a pirate's favorite letter?
And then other users can come in and say how they think the joke should end.
He likes R, but the C be his first love.
Other users can then come in and vote for their favorite combinations.
So for our sample app AnyJoke, we'll use this simple schema. Just remember, we didn't need to predefine any of this. We'll use the special Parse user class, and we're not going to add anything to it. We're just going to use the provided username and password fields. When people submit the start of a joke, we'll store those in the setup class, where we'll store the start of the joke in a column called text, and we'll store a pointer to the user who submitted the joke in a column called author. For all the various punchlines that people submit, we'll use the punchline class, where we'll store, again, the text of the end of the joke in the text column. We'll store a pointer to the user who submitted the punchline, and a pointer to the actual setup. That's important so we can link those together. We're also going to store the number of votes the punchline has received, and an array of the people who have voted for it in the voted user's key. Later on, we'll use Cloud Code to secure that, and our security options. So, sorry, let's take a quick look at the security options available for Parse data. For each class, you have the ability to set very precise access rules. It can range from the simple of giving just read and write permissions to users or groups of users or roles, to setting very specific rules about each of the different actions that can be done: creating, updating, deleting, finding records with a query, getting records by an object ID, or adding fields to the schema. And on top of that, each object in Parse can have an access control list, which can specify which users or roles can read or write to it. So for our punchline class in AnyJoke, we're allowing anyone to get, find, or create punchlines. But they can't update or delete or add any fields to the schema. We have a role called admin, and any user in the admin role can actually do all those other things, but also update and delete records. And then Christine's user account is able to update records. So with Parse, you could save a lot of time. And one of the ways you do that is by not building another user login and sign up flow. I mean, I've done that a lot over the past many years, where you get an idea and you start to build out the app. And one of the first things you usually do is build out login and sign up to actually get accounts. Sometimes it takes a while, and by the time you're done with it, you've kind of lost motivation on working on this new idea that you had. So stop doing that. The Parse user system is great. It's very easy to get up and running, just a couple of minutes, especially in something like a JavaScript web app. And for other platforms, we've released a very customizable open source UI framework for Android and iOS. It makes it super easy to add login and sign up screens to your app without building everything from scratch. Let's start looking at some actual code. Signing up a new user in your Parse app could not possibly be easier. So we'll start with JavaScript, as that's what AnyJoke is written in. You simply create a new parse.user, set the username key, set the password key, and then call signup and provide the function to actually run when this is completed. If you're an iOS developer, it looks very similar, except we use pfuser. We set the keys on the dictionary, and we call signup in background with block, providing the code block to run when it's done. And on Android, we create a new parse user. We call set username and set password, and we call signup in background with a new signup callback. Now, once you have a parse user signed up, let's look at what it looks like to log them in next time. So on JavaScript, it's very simple. We call parse.user.login, and again, provide the code to run afterwards. In iOS, pfuser.login with username in background. And in Android, parseuser.login in background, providing the callback. So once you have a parse user object, you could store a lot more data on it than just the username and password. It's a lot like a regular parse object, which Christine will tell you about now.
Parse objects are our single unit of storage. They belong to a particular class, and you can store arbitrary data on it in each of its properties. We've designed the parse experience to get out of your way as much as possible. So even though we told you which classes we were going to use and which columns we were going to use, you don't have to do that to get started. You can just start sending us data. We'll infer the classes and columns as you go. One thing to note, as your app moves toward production, what you should do is you should go in and actually lock those classes down with the security panel Fosco showed, just so that this early flexibility doesn't then become a vulnerability down the road. We get out of your way, and we try to make the SDKs fit as seamlessly as possible by matching platform conventions, as you saw. In particular, with parse objects, we try to make them feel as much like dictionaries as possible. So on iOS, you can use the same bracket format or syntax you just saw, or set object for key. On Android, plain put. .NET, something like set property. We're not only flexible about what you store, we're also flexible about how you store them. If the dictionary approach isn't your style, it's just a matter of subclassing these objects and then implementing whatever functionality you want on top of that. Not only, we saw the asynchronous version with Fosco's login examples, but we also offer synchronous versions in case you want to handle your threading yourself. And for our mobile SDKs, we also offer what we call an eventually option. This means that if you're trying to save an object and your phone isn't currently online, we'll actually take that request, serialize it to disk, and only when your device is back online will we try to send it to Parse's servers. We manage that for you, and we just make sure the save happens eventually. Let's take a look at what our objects will look like. So we've got a setup that the user types in, and they hit submit. What happens? We initialize a parse object and point it at the setup class. We'll use the user-provided text, whatever joke they choose, and set the author pointer to the current user. One of the benefits of using Parse's login signup flow is, besides how easy it is that parse.user.current will always be populated for you. Rather than having to maintain your own sessions and cookies and figure out from the session which user it is, parse.user.current will have the current user, and if they're not logged in, it'll be null. Some of you might be looking at this and wondering why we're saving a full object as an author instead of maybe foreign keys, maybe instead of storing the ID itself. This is an example of Parse trying to make things easier and more consistent for you. Rather than having to keep track of which properties are IDs and which properties are objects and which ones to populate and which ones require an extra lookup, everything's an object. And you'll see a little bit later when we're actually doing our queries how much easier that makes life. Once we've set these properties, it's just a matter of saving, and we can go on with our lives. On iOS, parse object equivalent, pf object. You set the properties, use current user, and save in background with block. Java, same thing. Parse object, setting the attributes, save in background with a callback. Creating the punchlines is only a little bit more complicated because we're saving an extra pointer. Let's take a look. creating an object, pointing it at the punchline class, setting the text, apparently chicken crossed the road for squeegees, and we'll set a pointer to the setup object that we started with, current user, and save. Parse object, again, equivalent, PF object, current user, save in background. You get the idea. Once you start working with Parse on one platform, it starts to feel pretty natural to jump to another platform and implement the same data fetching. If an object is our unit of storage, queries are how you access that storage. No matter what environment you're coming from, the constraints will probably seem pretty familiar. You've got filtering, you can do equality or range queries, anything like that, ordering, and limits. We try to bring the same synchronous, asynchronous flexibility that you saw with objects over to queries as well. We'll see asynchronous queries in these examples. You can use synchronous if you're handling your own threading, or if you're just debugging and want the data without callbacks. But we also support query caching on our mobile SDKs, where you can say, hey, this query, I just want the results, and I want to serialize them to disk. That way, the next time this query runs, I'll be able to choose whether to hit only the cache, only the network, or one and then the other. On iOS and Android, we take this one step further. We actually offer a local data store so that you can actually pin specific objects to disk and say, hey, I want this to be available all the time, even if I'm entirely offline. Let's take a look at how we'll be implementing our index page or our various pages with parse queries. So our landing page should list a number of setups and invite new users to come suggest punchlines. We initialize a query and point it at the setup class, and we include the author. This means that when we access the results, we don't have to do another lookup to figure out who the author is or maintain some map on the client. We'll just have the author there, and we can pull the name, populate the author name in the UI. We'll show 10 on the front page, and we'll just show the 10 most recent. Simple. We'll just get started. And this sort of callback syntax should start to look a little familiar by now. iOS is very similar. Instead of parse query, PF query, include, limit, order, and then find in background with block. The Android example, again, instead of PF query, you have a parse query, but you have include, limit, order, find in background. Setting up the joke detail page, again, we have that setup pointer. So we'll start off with displaying the setup at the top of the page and display candidate punchlines. We have a parse query pointed at the punchline class. We'll set this constraint. Here we can just set equal to directly to the object instead of, again, worrying about IDs and pulling IDs off things. We'll order by popularity, just so we can see which ones are the most popular at the top. And including the author, so we have the author name available. iOS and Android, you can kind of imagine what's coming next. In the Android.
So Cloud Code is our solution for application logic which actually runs on the server side. Currently, you write it in JavaScript and deploy it to the Parse cloud. You can access it from all the various platforms. Now, one of the benefits is that you could change this as often as you like, and you don't need to worry about resubmitting your mobile apps and dealing with App Store review policies. And since Cloud Code is running on the server side, and the code itself is not exposed to your users, you can do things that you don't want the apps to be able to do. Validate things, enforce custom security rules, business logic, and make changes that override security. Cloud Code is broken up into a few separate areas. The first one is database triggers. So whenever an object is saved or deleted, you have the option of running some code, both before and after the operation. When you use a before save trigger, you can validate the action, modify what is being done, even reject the action entirely. The same goes for before delete. After the operation is complete, if you didn't reject it, you have the option of using an after save or after delete trigger. You may want to update or delete some other object, or propagate a change to some third-party service. It's really up to you, but we give you this flexibility to build complex features. For example, we'll create a before save trigger on the punchline class. We define the function in our cloud code by calling parse.cloud.beforesave, telling it the class that we're setting it up for, punchline, and then providing a function that's going to do the work. Now, this function receives two parameters. The first is the request object. This contains all of the details that you need to perform your work. And the response object, which is how we'll respond to it and say it's either a success and go ahead and save the object, or it's an error and we don't want to actually do that. So here we're going to require that punchlines are created by logged in users only. So we're going to check the request.user property. And if that's not set, we're going to return response.error and tell them that they need to log in. So while the user is available at request.user, the object that's being saved is available at request.object. Now let's imagine we've created some logic that will define a bad joke. So if we say this is a bad joke, again, we're going to return response.error and ask them to try a different kind of joke. Now if that all is good, then we're going to call response.success and allow the punchline to be created. Now assuming we let it complete, we'll look at a very simple after save example. It's defined the same way, parse.cloud.aftersave, providing the punchline class, and then a function that's going to do the work. Now here you only get one parameter, the request object, because there's actually nothing to respond to. We're not actually waiting on this to complete, and there's nothing to do there. So here we're going to use an external service mailgun, and anytime a punchline is actually saved, it'll send me an email with the text of the punchline. Cloud functions.
Remember that cloud code is really ideal for logic that you want to take out of the client and put into a space controlled by you. Voting here is a really ideal example of this. We don't want that code on the client. Malicious users might try to find some way to reverse engineer our voting logic and upvote their own punchlines. Throw our whole system out the window. Remember, we'll be using the votes and voted users properties to modify this. We'll be using atomic increments on votes to keep track of the numbers and make sure they keep going up. Voted users will be using atomic array additions to keep track of unique users who've voted. Remember that in Fosco's security bit, we locked down this class to make sure that the punchline objects couldn't be updated by arbitrary clients. You'll see in a bit how we get around that because we're in cloud code, because we can tell Parse that, hey, this code is trusted, it's ours, don't worry. We're using votes and voted users here. Remember that if you end up realizing you want a little bit more flexibility with your implementation, or you just want to hide more of the implementation from this particular class, you can look into join tables, relations. There are a number of different ways you could model this. We've chosen this for simplicity. Let's take a look at how this cloud function looks. We define the cloud function. This allows the client to just say, hey, I'm calling this vote function and not have to worry about the implementation. And we have a request and response parameter. We have request and response parameters, just like Fosco showed in the before save. We want to fetch the punchline object that the function is going to talk about. And so we pull it off the parameters and get the object. And then we can get started with validating and updating. For once, the code here doesn't actually fit on one slide, so humor me while we split this across two. All that happens at the end is handling success and error. If there was an error that happened along the way, this way we can push back and tell the client, hey, your function failed. Figure out why. Once we have the punchline object inside the cloud function, we can check to make sure, hey, has this user already voted? Are they trying to vote twice? Return an error if they are. If you do take a look at our GitHub repo after this, you'll see that we actually check for a few more things. We make sure that the user's logged in. We make sure that the request.user is populated. And we'll actually make sure that users can't vote on their own punchlines, because that's not fair either. So once they get past this, we use parse.cloud, use master key to tell Parse, hey, I know we put in a bunch of access controls and permissions. We're good. This is cloud code. Let me do what I want. Once we have that in place, we can just increment the votes, add the users, and save.
Cloud Code is great, and we made it even better by creating and supporting additional cloud modules. We provide a collection of modules for third-party services like Stripe, Twilio, and Mailgun. We created some of our own, like the image processing module, which you can use for cropping and resizing images. And you can make your own and reuse them, share them with the community, whatever you like. Plus, networking is built right in. You can communicate with any external services directly from any part of your cloud code. You can also set up what we call background jobs. While database triggers and cloud functions typically happen while people are actually using your app, there are times where you'd want to run some logic ad hoc or on a schedule. Maybe something that runs every day. Maybe you're going to create some migration process. Background jobs are as easy to create as cloud functions and can be scheduled and kicked off from the Parse website. For our AnyJoke example, you could have a background job which puts together a daily digest of the best jokes and sends users a nice email. So let's take a look at what that might look like. So we'll make a background job that finds the top 5 voted punchlines and sends them. You define a background job with parse.cloud.job, give the job a name, and give it the function that will do the work. So similarly to before, this gets 2 parameters. The first is the request object that has all the details that you need to do your work. And this time it gets a status object. The status object can be used to mark the job a success, mark the job an error, or to update the message for this job. Since background jobs can run for a while, like 15 minutes, you might actually want to say, hey, I've processed 10 things, I've processed 100 things as you're going along. And they can be monitored through the job status page on Parse. So in here, we'll create a new query for punchline. We'll order it descending on votes, and we'll limit it to 5. And here we want more than just the punchline. We want the author of the punchline, we want the setup that the punchline is attached to, and we actually want the author of the setup too. We want to be able to put all that stuff together. So I want to mention here that the constraint methods on the parse query, they actually return the query itself, so you can chain calls. So here we're calling query.include, we want the author, then we call .include, we want the setup, and you can even use dot notation to include objects in objects you're including. So we will include setup.author. Then you run find, and you get an array of all the top 5 jokes. So let's assume that we've looped through here and put an email body together, and then we're going to use Mailgun to go ahead and send that email out. And then yesterday, we announced the latest addition to Cloud Code, Webhooks. This is great if you don't like programming in JavaScript, or if you do have some backend experience and you want to be able to host some of your own code. This supports all of our different database triggers and cloud functions. And since you're using your own resources, you get some relaxed time limits and some greater flexibility. As long as you have a server running somewhere on the internet, you can set up a webhook, and we'll call you when objects are saved or deleted, or for certain cloud functions. And you could do whatever you want, and then just respond to us to let us know how to deal with the response. One thing I want to mention about Parse Push is the installations. When you add push to your app and users subscribe for push notifications, we'll create an installation record with details about the user and their device token, etc. So there's a lot that you can do with this. It's just like a parse object. You can add all sorts of extra information. And that's the best way to target your users. If you're going to send push notifications based on certain criteria, it's best if you store that data about the user on the installation record. For example, if your app used location services, you could store the user's last known location on their installation. And then you could send targeted push notifications based on geolocation. There's also the concept of channels, and every installation object has an array of strings called channels. And you can add stuff to users' installation records and then send push notifications to everybody who's subscribed to a channel. And you can even send pushes to everybody.
With all of these pushes going out, it's often nice to know, are they working? Is anyone listening? Are they bringing people back to my app? With a line of code, put it in the right place. And you can tell us when users are opening your app. With that, combined with knowing which pushes we're sending, we can tell you things like, hey, this push was really effective. This push was not effective. And it actually lets you combine all of that into A/B testing. It lets you know whether it's more effective to send pushes to your users at 10 o'clock a.m. or 10 o'clock p.m., or let you compare messages. With all this data flowing through Parse, all of your requests already coming in, it only makes sense that we should be able to show you some data about how your app is working. We show you a number of graphs and metrics about the API requests that we're receiving from your app. This is really useful for, again, kind of just getting a general sense of activity, for debugging. I'm getting tons of updates on this class. I'm getting not very many updates on this class. Does that map with what my app is doing? Does that not? And this stuff doesn't require any additional work. Requests that you're already making to Parse, we know. Each time you execute a Parse query or save a Parse object, we know that translates to a find or a create. And on top of those two, we have even more advanced reports. This up here is an example of our retention chart, which ties into the concept of Parse users and allows you to split up your users into cohorts. How many of my 5-day-old users have been coming back? How many of my 10-day-old users have been coming back? On top of that, we've taken a step away from these sort of pre-aggregated results. And yesterday we announced Parse Explorer, which allows you to dive into the heavily denormalized kind of log data of, oh, this thing happened at this timestamp with this metadata. This thing happened at this timestamp with this metadata. Really intended for you to be able to debug what's happening in your app, how your app is using Parse, and which users are being affected.
Stay out. There's a lot more to Parse that we haven't covered in great detail today, like crash reporting, Parse config, local data store for iOS and Android, Parse for IoT, and much more. Check out the sample app, AnyJoke. It's at anyjoke.parseapp.com, and you can get the full source code from the GitHub repository. Come see us at the garage and get a copy of our new Pocket SDK reference guide. It comes with samples in 4 different languages. Thanks for attending our talk today. We can't wait to see what you build with Parse. And we're here and at the garage for questions, and we encourage you to come back after the break for more detailed sessions on Parse. Thanks.
Yep. I think there are mic runners.
There are a couple mics for questions.
We've got 7.5 minutes until they kick us off stage, so.
Hi.
Hi.
I'm Chris. We are doing the video app, and then we get the experience. When we use our app in the United States, it's faster compared to we use our app in Asia. So in this case, I just want to know, do you have any plan to do the CDN in the near future?
So this question was actually asked yesterday. I'm pretty sure that I can say that it is in our plans in the very near future to have some sort of some machines in the Asia region. I don't know the specifics or whether I'm allowed to say them. But come to our booth afterwards, and I'll check what I can say.
With respect to your Webhooks, how do you handle like failures or not reaching pages? Do you guys retry this so that it actually does the points correctly?
Was that about webhooks?
Yeah, Webhooks.
At the moment, there is no retry. This is the first version. We'd like to see how this performs. So it will fail, and you'll find that in your logs.
There's a little status icon. Does that tie to 500s?
I will have to check on that.
Okay. Webhooks are brand new. We'd love you to try it out and let us know what you want.
Yeah, we definitely want your feedback on that.
Hey, the analytics results you showed, they were for the example app, right?
They were not for the example app. The example app has not been around long enough to get that sort of usage. I think that was for one of our old sample apps, AnyPick, that we built several years ago and has sort of been in the App Store for a while.
Hey, how does GraphQL fit in this picture?
GraphQL is a way of accessing Facebook, the Facebook graph, which is pretty divorced from what Parse provides. Parse's database is really a separate store for you, for your app.
Are you going to have like a GraphQL layer on top of this so you can like, make a query with Parse with that?
It's possible. It's possible. We'll look into it.
Hi. We're developing an analytics app where we are storing a lot of data. And while I can see Parse being really good for user management and all that features, would you recommend using Parse when storing a lot of data? Or should we like keep that separate?
Parse is pretty good at storing lots of things. There start to be some performance concerns when you're doing heavily constrained counts. I think there are a number of apps that will do their own analytics by just kind of storing them in different classes and running queries over them. But you are going to take a performance hit by having kind of very, again, denormalized data in a store that's not optimized for that.
But we do have many apps with tens, hundreds of millions of objects.
Can Parse run locally on my machine? And how about the cloud code? Can it run locally and how to deploy to the Parse server?
There's no local version of Parse. However, with the new Webhooks functionality, it's possible to use a service that you can run your local cloud code and use Webhooks to test that there.
Does that mean every change I made, I have to push to the Parse server to test? Right?
Yeah, that's typically how it works, yes.
And this is only true for cloud code. So if you're building any kind of sort of, again, any more sort of mobile app, anything with just accessing the objects, often what people will do is if they don't want their apps to be making production requests in development, they can either mock it out or,
Use a separate app.
yeah.
Can you talk about the performance when you do include objects? How does that?
Well, since including an object is a very simple get, it's very fast. Right, and you can actually store like an array of objects, and when you call include, you'll get all those objects that are included in that. Doesn't seem to have any major performance impact.
There's often less impact by having us do the includes for you rather than having to incur the round trip cost of like fetching a bunch of object IDs and then unwrapping them and then requesting them again.
Hey, Darren. So when you were setting the password, it's in string format. What happens after that? So can you talk about the security and how you're handling it?
They're stored as decrypted strings, and all communications to Parse are done over SSL.
So how long does it exist in memory form? Is that done immediately once that function is called, or does it sit around for a while in residence?
There is no login eventually or send-in eventually, so those are basically executed immediately and sent to our servers.
You showed some analytics about the apps. Is that information? All right. You showed the analytics about the apps. Is that information accessible via REST or something else to third party?
Not right now. Not right now.
Is that in the pipeline? Is that in the plan?
It's something that is consistently asked about. We have a number of apps that will actually wrap Parse and provide white-labeled service externally. It's something that we know is valuable, especially as we roll out new features. And so I think the more things that we roll out that people want to access through an API, the more we prioritize that as well. So I think it is in our pipelines. We know about it. There are just some kind of non-implementation questions that we have to sort out.
Hi, so security is really important to me, and I was wondering how battle tested is the Parse platform and guarding against man-in-the-middle attacks, and what SSL layers are you using 2048 encryption layers, and how are you encrypting in a way where we can ensure that our users and our personal information that we transfer back and forth is really, really what best to be protected?
Yeah, I don't have specific details on what the bit level of the ciphers that are being used. However, I can assure you that being part of Facebook, we're part of the White Hat program. There are thousands of people attacking every little portion of us to enable to find loopholes. And we've fixed a ton, and we're pretty confident it's incredibly secure. Everything is SSL. Even though we just added this webhook stuff, we require that you have a legitimate SSL certificate. Self-signed certificates won't be accepted in order to protect against, man-in-the-middle attacks. It's very important to us to protect our users and the security of our apps.
And to provide the tools that let users protect themselves. Security tools, again, access control lists, class-level permissions. We have a lot of documentation around how to use all of these because we want to make sure that, beyond just man-in-the-middle attacks, how can someone social engineer their way around some sort of, So look into that as well. All right.
All right, looks like our time is up.
Come find us at the booth if you have other questions. Otherwise, please stick around. There's some really cool intermediate and advanced talks on Parse. So thanks.
Thank you.